Alright, number 1, we get to choose what method we want to use to solve, but I see that the first equation is already solved for y, so it's y equals. So that seems like a great substitution problem. To make this an elimination problem would take probably too much work. So it's easier to take what y is equal. Let's set equal to negative 2x plus 6 and substitute negative 2x plus 6 in place of y in the other equation, because I know y is the same as negative 2x plus 6. They're interchangeable. So since they're interchangeable in that other equation, I replace y with negative 2x plus 6. I have to put it in parentheses because there's two terms, but it goes in place of the y, and then finish the equation so it equals negative 10. So now at this point distribute the negative 3. Careful, because of that negative, take it with you. Negative 3 times negative 2x is positive 6x. Negative 3 times 6 is negative 18. Equals negative 10. The 2x and 6x are on the same side of the equation, so combine them together. 2x plus 6x is 8x. So 8x minus 18 equals negative 10. Add the 18 over. 8x equals 8. So divide by 8, and we see that x equals 1. So now we have to find the y value that goes with it. So take and plug that in. Plug it into one of the equations. I would prefer to plug it in the first one. The y equals, so y equals negative 2 times x, but replace the x with 1. Now that we know the intersection point has an x value of 1. And then plus 6. So negative 2 times 1 is negative 2. Add 6 to that, we get 4. So 1, 4. I can write my answer as an ordered pair. Number 2, notice there, x equals 0. It's already solved for x. Plug that into the other equation. This is also a substitution problem. So it would say y equals negative 3 times 0 plus 7. Negative 3 times 0 is 0, plus 7 is 7. So y equals 7. We need to know what x equals, but notice it already told us x equals 0. You could plug 7 into the first one and do 7 equals negative 3x plus 7 to find x, or recognize it says x equals 0. We already know what x is. So 0, comma 7 is our solution to this one. Number 2, you could use elimination because it'd be easy to get the second equation for x by itself, but I prefer elimination, so I'm going to go with that one. I see the first equation has a 2x, so I'd like the second one to have a negative 2x. I can do that if I use a multiplier of negative 2. So the first equation is going to still say 2x minus 3y equals negative 9. The second equation, when I distribute my negative 2, that multiplier, I get negative 2x, then negative 2 times 2y is negative 4y, and then negative 2 times negative 1 is positive 2. Now combine, add those two equations together, the x's eliminate. Negative 3y and negative 4y make negative 7y, and negative 9 plus 2 is negative 7. Divide by negative 7, and I see that y is equal to 1. So now that we know that, plug it into one of the equations. Any of the equations, either one of the originals or one of the new ones. I'll go to the original, the x plus 2y, because it has the smallest numbers, but really you could plug it into any of them. But now replace the y with 1. So it says x plus 2 times 1 equals negative 1. 2 times 1, of course, is 2. Subtract 2. You get x equals negative 3. So the ordered pair then, the x goes first, so negative 3 comma 1. Number 4, doesn't look like a good substitution problem. I'd probably use elimination. Notice I made the mistake on the worksheet. I didn't put a negative in front of the 6, but it should be there. I asked everybody to change that, so hopefully you did. Otherwise, it's not a very nice answer. But let's get rid of, it doesn't really matter if you get rid of the x's or the y's. The y's have smaller numbers, 3 and 2. They both go into 6. So maybe we'll make them 6's. So the first one's already negative, so let's make it a negative 6y. That means it needs a multiplier of 2. So distribute that, you get negative 12x minus 6y equals 10. So then the second one, I want it to be a positive 6y. It's already positive, so I just need a multiplier of 3. So distribute, I get 12x plus 6y equals negative 12. Add the equations together. The x's eliminate, as do the y's. So all that's left on the left side is 0. On the right side, 10 minus 12 is negative 2. So if 0 equals negative 2, since everything's eliminated, it's either infinitely many solutions or no solutions. So consider the truth value of this. Does 0 equal -2? No, that's not true, so that means there is no solution. Number 5. You could substitute here because we've got an x without a coefficient, but I'm going to go ahead and choose elimination, especially when I can turn that first equation into a 2x, because I already have a -2x below it. So I'll use a multiplier of 2. 2x plus 6y equals 28. Second equation can stay the same. Combine like terms. X's eliminate, as do y, so the left side is a 0. The right side, oh, that becomes a 0 also, so I get 0 equals 0. Everything's eliminated, but now it's a true statement. 0 does equal 0. That means that there are infinitely many solutions. It means the two lines were the exact same line. The same line right over top of itself. So there's an infinite number of intersection points. Number 6. 2x minus 6y equals -3. Okay, so this looks like a good elimination problem. Maybe I go for 6 x's. First one's already positive, so I'll use a multiplier of 3. Distribute 6x minus 18y equals -9. Second equation, I'd like a -6x, so I need a multiplier of 2. -6x plus 8y equals 14. Combine 6x and -6x eliminates. -18 plus 8y, that's going to be -10y. -9 plus 14, that's 5. Divide by -10, looks like we're going to get a fraction, but at least it's not a bad fraction. 5 over 10 is 1/2, put the negative out front, so it's -1/2. So now we have to find out what x is, so plug that into one of the equations. Doesn't matter, maybe I'll use the top one, the 2x minus 6 times y, y being -1/2, equals -3. -6 times -1/2 is +3. Subtract the 3. 2x equals -6. Divide by 2, we see that x has to be -3. So we should have the order pair -3, -1/2. Number 7. 480 tickets were sold. We have student tickets, we have adult tickets. We're trying to find how many of each. So we need to set up variables. You could use S for a student, A for adult. You could use X and Y. It's kind of up to you. I'm going to use S and A. So S, I'm going to let that represent the number of student tickets. That's one of the things I'm trying to find. A is the number of adult tickets. How do I know to do this? Well, whatever you're trying to find, that's what your variables should be. We're trying to find the number of student tickets, the number of adult tickets. So I just give them each a variable, whatever letter you want to use. And now I write equations based on that. Go back to the first sentence. 480 tickets were sold. Some of those were student, some of those were adult, but they totaled 480. So I know that the number of student tickets plus the number of adult tickets has to be 480. So that means S plus A equals 480. And then it talks about money. It says each student ticket costs $7. So if there's S student tickets, they each cost $7. 7 times S gives me how much money was made through the sale of student tickets. Adult tickets are $10 each. 10 times A tells us how much money was made selling adult tickets. When you add those together, it's the total amount of money, which was $4,275. So now we have our system of equations. That's the first thing they wanted. And now it says to solve them. So this could be a substitution, elimination problem, or graphing calculator. Looks like I might multiply the first equation by -7. Distribute -7a minus 7s, and then it looks like I need a calculator for that one. So -7 times 480 is -3360. And where did I get that from? I used a multiplier of -7 on the first one. Second equation stayed the same. And now I can add them together. The a's cancel. Up. Sorry, I messed up in that first equation. I messed up my A's and my S's. First one was an S, second one was an A. I really messed up the second one also, so sorry about that. So negative 7s and negative 7a, and then in the second equation, it was 7s plus 10a. Okay, so my s's cancel, is where I was trying to go with this. So negative 7a and 10a makes 3a. And then 4275 minus minus the 3360, we should get a total of 915. Divide that by 3, we get 305. So that means 305 adult tickets. Go back to remember there's 480 total. So student tickets plus, we know now there's 305 adult tickets. Total's 480. If I subtract the 305 from the 480, I'll see how many student tickets were sold. Looks like 175. Yeah, adult tickets 305, student tickets 175. Let's go to the back page. Okay, inequalities. So the first one, it is in slope-intercept form. I'm going to color code. Grab another color. Alright, so I'm going to use this kind of maroon color in the first one. Hopefully you can see that's maroon on the video. Positive 3. For y value, our slope is negative 2, so negative 2 over 1. So you go down 2, 1 to the right. 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 I could even go up to 1 to the left to get that top point. This is a dashed line because it's not equal to. Make sure you indicate that's a dashed line. And then I need to shade. I have to figure out which side, because that's the boundary. So one side of that line has solutions, one side has non-solutions. I have to figure out which side has which. So pick a point that's on one of the sides. I like to pick 0, 0, as long as it's not on the line. So it works here. So I'm going to plug it in. So let the x value equal 0, let the y value equal 0 into that same inequality I was just working on. So plug 0 in for the y. It's greater than negative 2 times 0 for the x, plus 3. Negative 2 times 0 is 0. And add 3 to 0. 0 plus 3 is 3. So the right side becomes just 3. 0 is greater than 3. Consider the truth value of that. Is that true? Is 0 greater than 3? No, it's not true. It's not a solution. 0, 0 should not be shaded. It was on the lower left, so the lower left should not be shaded. Therefore, the solutions must be in the upper right. So you can shade the upper right to indicate that's where the solutions are at. Now, for the second one, I'm going to try using blue. They're both kind of dark colors. Hopefully it'll show up on the video. Not real well, but hopefully they're distinguishable. Okay, negative 4. And then rise 1, run 2. The slope is 1/2, so rise 1, run 2. Rise 1, run 2. I could go down 1 and back 2 to get the other side of the line. This time it's a solid line because it's equal to. Okay, I have to figure out now which side to shade, so pick an ordered pair that's not on the line. I can pick 0, 0 again. I'll go to this side this time. So the x value is 0, the y value is 0. So go through the inequality. Y, so that's 0. It's less than or equal to 1/2 times x. X is also 0. Minus 4. 1/2 times 0 is 0. Subtract 4 from that 0. Minus 4 is negative 4. So 0 is less than or equal to negative 4. Well, 0 is actually bigger than negative 4 because negative 4 is negative. So that's not true. 0 is not less than it. So therefore 0, 0 is not a solution. I shouldn't be shading above it. I've got to shade this lower right. I'm going to jump down to number 10 right below it because it refers back to that graph. Number 10 says use number 8 to answer the following. Give a solution. So a solution is an ordered pair that is true of both of them. So it's an ordered pair where the shadings are overlapping. So pick one of the points where it's overlapping. I'm going to pick this one right here. Looks like that's the point 5. -3. Now, there's more than one answer you could give. That's just a sample or an example of what you could be. But whatever you give better be in that shaded area, the overlapping area. I can even, you know, shade it a little darker, a little bolder if you're struggling to see where they overlap, but they overlap in that section. And now for B, given non-solutions, that's an order pair that's not in that region. It could be anywhere outside of that, as long as it's not in that shaded region. So maybe I'd give 0, 0 as the sample answer, because that's not in the overlapping area. But there's an infinite number of answers that you could give. That's just one of them. Okay, number 9. So this time we've got 3, so I'm going to use 3 colors. I have the same 2 colors plus black. They're all dark, so it's a little hard to tell, but hopefully it'll work. So the first one, I'm doing this maroon. X, oh, this is an X equals, not a Y equals. That's a vertical line. Hopefully you remember that. Or if you don't remember it, find some ordered pairs. Let's make some ordered pairs that are solutions. What do we know? The only restriction here, pretend it's an equal sign when you're finding these. The only restriction here is that X is -2. So in every one of those ordered pairs, you have to have an X value of -2. It doesn't say anything about Y, which means we can do whatever Y values we want. I could do like 0, 1, and 2. If I plot those points, -2, 0, -2, 1, -2, 2, I start to see, oh, they make a vertical line. That's the pattern we see there. Since it's not equal to, it needs to be a dashed line. I have to figure out whether to shade to the left of that or to the right of that. So pick an order pair that's on one of those two. So I'm going to pick 0, 0. 0 for X, 0 for Y, plug them in. The inequality says X, so plug in 0 for X is greater than -2. There's nowhere to even plug in Y. So it says 0 is greater than -2. Is that true? It is true. 0 is greater than -2. So it's a solution, therefore, everything to the right of that line needs to be shaded. Okay, now let's go to the next one. I'm going to use blue. This one's in standard form, but it's really easy to get by Y. If you can get the Y by itself, if you subtract that X over, so minus X plus 2, that's in slope-intercept form. Maybe that's what you'd like to do rather than finding the X and Y intercepts. It's pretty easy to do that. So find your Y-intercept of 2, and your slope is -1. So -1 over 1. Go down 1, 1 to the right. Or if I went the other side, up 1, back to the left. Up 1 to the left 1, up 1 to the left 1. Okay. Solid line this time because it's equal to. And then I need to figure out where to shade. So pick a point on the line, like 0, 0. I could pick 0, 0. Let X be 0, let Y be 0. Go back to the standard form of the original. It's really easy to plug it in there. 0 plus 0 is less than or equal to 2. So it's 0 is less than or equal to 2. Is that true? 0 is less than or equal to 2. That's true. So 0, 0 should be shaded. It's to the lower left, so shade everything to the lower left. And then for the third equation, I'm going to go to black. Hopefully that's discernible slightly. This one doesn't have an X. Y is -1. So just like we did on the first one, if you're not sure what that is, take some ordered pairs and make some solutions. The only restriction here is that Y has to be -1. So in the Y value of everyone, put -1. But it doesn't say anything about the X's, so you can have whatever X's you want. So I could try 0, 1, and 2. Graph those points, 0, -1, 1, -1, 2, -1. We see that it's a horizontal line with a Y value of -2, or a Y-intercept of -2. So it looks like a dashed line. Okay, this graph's getting really busy. Got to tune everything out. Focus on just that horizontal line there. Whether we figure out whether to shade above or below. So pick a point that's either above or below, like 0, 0 is above it. So I can test 0, 0. Plug 0 in for X, 0, 0 for Y. So Y is greater than 0, or greater than -1, so we're plugging 0 in for Y. 0 is greater than -1. Is 0 greater than -1? Yes, it is. 0, 0 is a solution, so it's above it, so I should be shading everything above it. So where is the overlapping region, especially when it's so messy with 3 pictures? I've got this triangle. All 3 of them are overlapping right here. I'm going to make a bold side of that triangle. And now down below, number 11, uses that graph. It says, hey, give a solution, give an ordered pair that's in there. I might use 0, 0. It's in there. It's not the only one. You can use 1, 0. You can use negative 1, 0, or negative 1, 1. I mean, there's several ordered pairs you could pick, but 0, 0 is one of them. Now give something that's not in that region. Okay, so be careful, make sure you're well outside, but I wouldn't get very close to the line in case your line isn't perfect. Maybe you get a ways out there. So maybe I go to 5, I don't know, 5, 5, clear up here. That one's definitely not in that shaded region, so that's fair game. That would be a sample of a non-solution. 5, 5, but there's all kinds of other ordered pairs you could have found as well. All right, thanks for watching.